Have you ever looked up at the night sky and felt a profound sense of smallness? It is a feeling we all share. We are connected to those distant points of light in a way that is almost impossible to comprehend. The sheer scale of the universe is something that challenges the very limits of our human imagination. Our minds are built for the distances we can walk or drive, the space between our homes and the horizon. But the cosmos operates on a completely different level of reality, a scale so vast that our everyday measurements like miles, kilometers, become utterly meaningless. To even begin to grasp these distances, we must change how we think about space itself. To navigate this immense emptiness, astronomers had to invent a new kind of ruler. This ruler is not made of wood or metal, but of light. We call it a light year. Light is the fastest thing in the entire universe, traveling at an incredible 186,000 miles per second. A light year, then, is the distance that a single particle of light, a photon, travels in 1 year. It's a journey of nearly 6 trillion miles. Think about that for a moment. If you were to travel in a car at a steady 60 miles per hour, it would take you more than 11 million years to cover the distance light crosses in just one. This is the fundamental unit we use to chart our cosmic neighborhood. Even with this new, enormous ruler, the numbers quickly become staggering. The nearest star to our own sun, Proxima Centauri, is a little over 4 light-years away. This means the light we see from it tonight began its journey toward Earth more than 4 years ago, when the world was a different place. When we look at that star, we are literally looking into the past. Imagine embarking on a journey there. Even with our fastest spacecraft today, it would take tens of thousands of years to arrive. It is a distance that separates stars, a vast cold and dark ocean of nothingness that makes the space between planets in our own solar system seem like a short stroll across a garden. Our solar system itself, which feels so large to us, is just a tiny speck. To cross from the Sun to Neptune, the most distant planet, would take a beam of light about 4 hours. Compare that to the 4 years it takes to reach the next star. This illustrates the profound emptiness that dominates the universe. Space is not crowded. It is defined by the immense voids between things. The distance from our Sun to the center of our own galaxy, the Milky Way, is about 27,000 light-years. The starlight from the galactic core that graces your eyes tonight started its journey when early humans were first painting stories on cave walls. Every star is an island, separated by an ocean of time and space. As we pull our perspective back even further, the scale continues to expand in ways that defy belief. Our Milky Way is a magnificent spiral city of stars, containing perhaps 400 billion suns like our own. It is a vast, swirling disk of gas, dust, starlight, about 100,000 light-years from one edge to the other. If you could look down upon it, our entire solar system would be an invisible dot in one of its spiral arms. But this colossal structure, our home galaxy, is just one of countless others. It is a single grain of sand on an infinite cosmic beach, a single island in an archipelago of galaxies that stretches on and on. The best scientific story we have is the Big Bang. About 13.8 billion years ago, everything we see, all the matter and energy in the entire observable universe, was concentrated into a point of unimaginable density and heat. It was a singularity, a state smaller than an atom. And then it began to expand. This was not an explosion in space, but an explosion of space itself. In the first fraction of a second, the universe inflated at a speed that defies all logic, growing from the subatomic to the cosmic in a blink. As the universe expanded, it cooled. The fundamental forces of nature emerged, and the first simple particles, protons, neutrons, electrons, began to form. For about 380,000 years, the universe was a hot, dense, opaque fog of plasma. Then, as it cooled further, atoms formed, and the universe suddenly became transparent. The first light was finally free to travel across the cosmos. That ancient light is still traveling today. It is called the cosmic microwave background radiation, a faint uniform glow that fills the entire sky. Over hundreds of millions of years, gravity began to pull matter together. Tiny fluctuations in the early universe acted as seeds. Gas and dust gathered into enormous clouds, which collapsed to form the first stars, the first galaxies. These early stars, massive and short-lived, forged heavier elements and scattered them across space. We are, in a very real sense, made of stardust. The expansion that began with the Big Bang has never stopped. It is accelerating, suggesting a mysterious force, dark energy, pushing space-time apart. If this acceleration continues, we may be heading toward the Big Freeze, galaxies disappearing beyond a horizon, stars burning out, the cosmos growing darker, colder, emptier. The observable universe is a sphere about 93 billion light-years wide, but likely not all there is. Beyond our horizon may lie endless cosmos, perhaps even a multiverse.